Welcome back at C-Square. In this lesson, we will talk about area of regular polygons. And you see in our picture, we have two regular polygons, an pentagon, the first one, 5 sides, and an hexagon, the second one, 6 sides. So what you also see here is the center of these two polygons, which allow us to break that polygon in a number of triangles. In this case, 5 isosceles triangle. In the next case here, this is even a very special case. We have 6 equilateral triangle. Okay, and the idea here is if you find the area of one triangle for the first one, the pentagon, you multiply by 5 and you get this area of this pentagon. And the same for the second one, you find the area of one equilateral triangle, you multiply by 6 and you get the area of the hexagon. But however, there is another way to do it, and this right here on this line there is a formula, this one, which says area of a regular polygon is 1/2 times A, which stands for the apodum, and P, which stands for the perimeter. Okay, so let's see first of all what the apodum is this segment, for example, one of them that goes from that point T is perpendicular on side AB, one side of this octagon you see here. Obviously we have multiples apodums. This one is another one, or this one is another one. Oops. So we have 8 of them. Okay, so a lot of choices here, right? Remember, it has to be perpendicular, and once it's perpendicular, it breaks the side into equal parts. That's going to be a key word in this lesson today. So let's take a look to the first problem. Find the area of the regular polygon. If AB is 5, so that means this side is 5, and TP, which is the apodum, it's 6. So this is the problem where you just use the formula 1/2 times A times P. We're gonna plug the things in. Then we're gonna have 1/2 times A, remember, is that apodum, 6 in this case, and the perimeter in this case will be what? This 5 is given to us times how many sides we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 sides. It's an octagon, like I said before. So this will be 40. So I'm going to go back in this formula and I'm going to put this 40 in here. And this problem can be done without a calculator. 2 goes in 6 3 times, and we have 3 times 40 left. And that means this area is 120 square units. Okay. You see here I said most of the time you have to use trigonometry for finding different parts of regular polygon before finding the area. Yes, because most of the time you will not get both parts, the apodum and the side. You don't need, in fact, both of them. You need only one of them. Like in this case you see here, find the area of this hexagon, pentagon, 5 sides, and we know only the fact that this side is 10. So my first thing will be here to mark the center, okay, and I'm gonna want to find first what we call a central angle of this polygon, this one, and that will be nothing else than 360 divided by 5. Why 5? Because I can draw 5 angles like this just by connecting this center with each vertex here. So that will be 72 degrees. But moreover, I want you to take a look what I'm doing now. I'm going to draw this segment perpendicular from the center to this side. Oh, this is the apodum? Yeah. And that will cut this central angle in 2 pieces. So my next thing will be to do 72 divided by 2, and that will be 36. Okay, so each angle, this one or the other one, it's 36 degrees. So now another thing that you want to do very fast is to remember that these two parts are congruent. this apothem bisect this side AB. So each one is going to be 5. So my next thing will be to draw one of these two triangles. It really doesn't matter which one. This is 5. This is the apothem we need to find out. This is a right angle, and this angle is 36 degrees. So how do I find this A now? Like I said 1 minute ago, 2 minutes ago, we're going to use the trigonometric ratio, and the one that connects the angle 36 degrees, the opposite side 5, and the one we need to find out, the apothem, which is the adjacent, is the tangent. So I'm going to write here tangent of 36 equals opposite 5 over A. And in my channel you can find the lesson about trigonometry. Please watch them. In this case you can just switch A and tangent and you get A equals 5 over tangent of 36, which is the exact answer for the apothem which we need. Okay, I'm gonna leave it like that, and I'm gonna move to finding the area. That's what is asked. And if you remember, area is 1 over 2 times A times B. So what do we have here? 1 over 2 times A, we did find it here. 5 over tangent of 36. And what about the perimeter? The perimeter of this pentagon, right, 5 sides, is this 10 times the 5 sides we have here, right, 3, 4, and the one we start with. So we have 10 times 5, which is 50. So that's going to be my next thing here to multiply by. Okay, very similar with what I did before. I'm going to simplify a little bit. If that is possible, I will suggest you these two goes in 50. 25 times. We have 5 times 25. That will be 125 over tangent of 36. This is the exact value of the area of this pentagon. However, let's give an estimation. So I'm going to use a calculator here, and I'm going to have 125 divided by tangent of 36, and I end up with 172.05. I round it to the nearest 100 in this case. Okay, so that is about this first example. Let's move to the next example, very similar. If you notice, now we have another type of problem where we have the apothem. This 10 is the apothem. So what we really need to find out now is how long the side is, how long this AB is. The math is very similar, a little bit different. If you remember, we have the same triangle. We can draw this one now. Really doesn't matter. This, if you remember, this one was 36. Okay, so basically now I'm going to draw that triangle, which is a right triangle, and this angle is 36. Now we know this 10, and we need to find, I'm going to call this X here first of all. So again, the trig ratio will help us here. Angle, we need to find the opposite. We have the adjacent, so tangent of 36, the same like the previous problem. The only difference now, we have what? X over 10. Okay, so when we solve for X here, we just multiply by 10. And we have X equals 10 tangent of 36. So now let's take a look to this problem. What is this X? This X is this piece, which is half of the AB. So AB will be twice this X. So it will be 2 times 10 times tangent of 36, and that will give us 20 tangent of 36. But AB is just one side of this polygon of 5 sides. So how do I find the perimeter? We did it before, very similar. We're gonna say the perimeter is 5, because we have 5 sides, times how long the side is, which is 20 tangent of 36. So that will give us 100. 5 times 20 is 100 tangent of 36. So now we can go in the formula. I had it before, if you remember. A equals 1 over 2 times A times B. And we're gonna get here what? We're gonna get 1 over 2 times A. A is 10. That was the first information given to us. Times B times 100 tangent of 36. We'll approach in a very similar way. 2 goes in 55 times. And we have here 5 times 100. So the exact value is going to be 500 tangent of 36. I'm going to use a calculator and I'm going to round it to the nearest 100. Of course, you know, if you need to a different rounding, just be careful. So we have here 500 times tangent of 36, and I end up with this value 363.27. Again, I round it to the nearest 100. However, there is a third case, the last case, in fact, I said here, when the radius of the regular polygon it is given to you. What do I mean by the radius? This piece, you notice, this is what we call the radius. We have obviously in this case 5 radii, one for each vertex. And why do you call them like that? Because this polygon can be inscribed, and this TA will be the radius of that circle that goes around the circle, circumscribe. In case you need these two words, inscribed, the polygon is inscribed, the circle is circumscribed. So how are we going to do that? Very similar. If you remember, we're going to draw this triangle, right triangle. How much was that angle? 36. So it's the same thing. Okay, and now we know this hypotenuse. Let me draw the triangle. Again, like I said, the right triangle. We know this hypotenuse. Then we need to find this segment, which is the apparent, this one. And we need to find this x. And remember, this angle is 36. So what do you think I'm going to use? Trigonometric ratios. So again, let's say if you find A. We're going to find A. For A, you have the angle. This is the adjacent leg and the hypotenuse. So that means cosine of 36 equals A over 10. So A will be nothing else than 10 times cosine of 36. So now we have A. We need to find the side of this polygon, right? For doing that, we're going to need to find this x here. And again, I'm going to use the trigonometric ratio. Angle, this is the opposite leg, and this is the hypotenuse. So that means we're going to use sine. And I think this is the best way to do it. There is not the only way now, since we have A, but I think it's the best way. So we have here sine of 36 equals opposite x over hypotenuse 10. So we end up with this x being 10 sine of 36. But if you remember from the previous problem, this is x. We have another x here. So AB will be twice this expression, which gives us 20 sine of 36. So now we can move to the next part, which is the perimeter of this shape, which is going to be 5, why 5? Because this polygon has 5 sides, times how long a side is, which is this 20 sine of 36. And that will be 5 times 20, 100 sine of 36. So if you remember now, we can go back to that formula at the beginning, 1 over 2 a times p, and we're going to replace the things in here. 1 over 2 times the apothem, is right here, 10 cosine of 36 times the perimeter, which is right here, 100 sine of 36. Again, I will simplify here, and again this 2 cancel this 10, that is one way to do it, and we have 5 times 100. That will be 500. 500 cosine of 36 times sine of 36. This is the exact value. It looks interesting if you are not familiar with trigonometric function, but that is the exact value. Don't get scared, you just need a calculator to evaluate this, which I'm gonna do it in a moment. I'm gonna do 500 times cosine of 36 times sine of 36. I end up with 237.76. Again, I round it to the nearest hundred. Okay. So these are the 3 cases you need to be aware in case you need to find the area of a regular polygon. My next part of the lesson will take a look to what is called composite figures. And in this case, we're going to take a look to composite figures that are made, or they can be divided into regular polygon. Like in this example. This example, we notice we have a pentagon, this one. The side is 8 inches. And right here, this is a regular polygon. This will be a square. Right, 4 sides. Each one is 8 inches. This is the regular polygon, by the way, with 4 sides. It's a square. So I guess I'm going to start with the square, right? Because the area of the square is side squared, in this case 8 square, or 8 times 8, and that will be 64. That is how much this area is. So this, in this case, this one is easy, not super complicated. Now we need to find the area of this pentagon. Okay, if you remember, again, the center, I'm gonna draw this apothem. This is a good triangle. Now remember, this is gonna be half of 8, let me be sure, and this is gonna be 36 like in the previous problem. So the same thing, and this is gonna be the apothem. So we're gonna have again tangent of 36 equal 4 over a, and a will be 4 over tangent of 36. So the same problem like we did before, the only difference with the side is 8. So the perimeter, by the way, of this shape, it's 5 times 8, 5 sides times 8, which is the length of AB. That will be 40 units. And now we can go back and find the area of this hexagon. I'm sorry, pentagon. I apologize. So that will be 1 over 2 times a, which is 4 over tangent of 36, times the perimeter, which is 40. Again, we can simplify here. 2 goes in for 2 times, so the exact answer will be of this pentagon to be clear. 2 times 40, that is 80 over tangent of 36. But what do you think will be the last step in this problem? The last step for finding the area of this composite shape is to add these two areas, the area of the square and the area of the pentagon. So in our case, the exact value will be this 64 we start with right here, plus this 80 over tangent of 36. This is the exact value, and I'm gonna do an estimation here. Again, I'm gonna round it to the nearest tenth. So you may want to start with the last part, to 80 divide by tangent of 36, and then add the 64. I think that's the best way to be sure you don't miss the answer. I end up with 174.11. This is the area of this composite shape. And my last problem in this lesson will be this one. Sometimes you need to subtract. You notice here we have an octagon, and from that octagon we take away that triangle, which is a regular polygon. That will be an equilateral triangle, so you need to be sure. And that triangle, by the way, is different than these triangles that gets from the center from here, right? So again, these two triangles are very different. No, they are not really the same. They are not congruent. Okay, but because I drew this triangle, the first thing I want to find is this angle. If you remember, 360 divided by 8. If you said 8, that's correct. Okay, because we have 8 sides now, and that will be 45 degrees. But remember, we have to divide that 45 by 2, and that would be 22.5. Why do we need to do that? Because that angle is this one. Okay, let me be sure. Is this angle? This is 22.5. Okay, and this piece here is the same with this. Is going to be half. It's going to be 5. So we had something like that. The only difference, it was a different regular polygon, so the angle was different. So yeah, this angle 22.5, and this is 5. What do we need to find here is this apothem. So again, we're going to use tangent of 22.5 equal 5 over a. So we're going to have a equals 5 over tangent of 22.5. So we have the apothem, we need the perimeter. The perimeter is going to be what here? We have that 10, the length of side AB, and we have to multiply in this case by 8 because you have an octagon, and that will be an octagon, I'm sorry, and that will be 80. So now the area of this octagon will be 1 over 2 times a 5 over tangent of 22.5, so times the perimeter 80. So let me be sure I use again this formula we discussed in this lesson. Very useful if you remember. Okay, in this case again I can simplify something. 2 goes in 80 40 times, so I have here 5 times 40, that will be 200 over tangent of 22.5. And now let's take a look to this triangle. This is 10, and very similar, I can draw this apothem okay, which we need to find out. Okay, so this angle here will be, if you said 60, then you are correct, because look at here, this central angle here is 120, right? 360 divided by, let me do that here, 360 divided by 3, that is 120, and then 120 divided by 2, remember we have to divide by 2, it's 60. So the new triangle that I'm going to use it, and I'm going to try to draw a very similar one, this one, right? This will be 60. This is the A we need to find out, this new A, and we know FE it's 10, so this piece will be 5. So again, this one will be 5. Okay, so we're gonna have the same, and in fact on this one you can use a special right triangle, 30, 60, 90. This angle is 30, and if you use this one, be careful, because this one is tricky. Let's use trigonometric ratio to be consistent. So we have, let me erase that 30. We have tangent of 60 equal 5 over A, and let's call this one A2 here, and let's call the other one A1, just to make a difference between these different A's. So A2, in this case, the bottom of the triangle we have is 5 over a tangent of 60. And one more time, if you know special triangle, you can get a different expression involving radicals, but we're still gonna do some estimation at the end, so this is not bad. Okay, the perimeter of this triangle will be the 10 we have here, right, times 3, because we have 3 sides, that will be 30. Okay, and let me be sure, this perimeter here is the octagon. Okay, so now we can find the area of this triangle, which is going to be 1 over 2 times A, 5 over tangent of 60 times the perimeter, which is 30. So again, we can simplify here. 2 goes in 30 15 times. We have 5 times 15, that will be 75 tangent of 60. What do you think is going to be the last step to find the shaded region? In this case will be a subtraction. So area of the shaded region is going to be the area of the octagon, the big shape, and we take away the triangle. So in our case here, we're going to have area of the octagon, that 200 over tangent of 22.5 minus 75 over tangent of 60. Be careful how you evaluate this expression here. This is the exact answer in case you need it. If you need to evaluate, be sure you do it correctly. Maybe you want to do these two quotients separately, put the answer down on the paper and then subtract them in order to be sure you don't miss it. I'm going to try to do it in one step just to be careful. Now I have 200 divide by tangent of 22.5. In fact, I can click equal here and I get that area of the octagon 482.84, and I'm gonna subtract from this one 75 divide by tangent of 60, and I end up with this value 439.54. And that's it for this lesson. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help.